Hi everyone. In this video, I am going to demonstrate how to simulate basic electronic circuits using LT-SPICE simulation software. It is a freely available software from analog.com. The link to get this software is given in the description. Here we simulate the VI characteristics of a normal PN junction diode in its forward and reverse bias conditions. In theory, we already studied how to make diode in its forward and reverse bias configurations. When the positive terminal of the battery is connected to the positive terminal or P region of the diode, it is called as the forward bias configuration. Similarly, when the positive terminal of the diode is connected to the negative terminal of the battery, or negative terminal of the battery is connected to the positive terminal or P region of the diode, then it is called as reverse bias. This is the diode symbol. Here, this part is the positive terminal or anode, and this is the cathode or negative terminal. And this graph shows the VI characteristics of the normal diode. Here, first column shows the forward characteristics, and this part, fourth column of the graph shows the VI characteristics corresponding to reverse bias condition. The one important thing we should not that here the x-axis is the voltage. What voltage it is? It is the voltage across the diode, not the source voltage. Here x-axis V is the voltage across the diode and I is the current passing through the diode. So in IV characteristics or VI characteristics, we are plotting V against I, where V and I are the voltage and current across and through the diode. Now let us try how to get this VI characteristics using LT-SPICE software. This is the LT-SPICE software, and it is the interface of LT-SPICE. Here the toolbar and menu bar are arranged here. In this list, the first one is the new schematic. By clicking this, we can start to draw the circuit. Initially, let us try the forward characteristics. How we can draw the circuit here? To draw the circuit, in the circuit we require one voltage source, resistor, diode, and a ground. We can just pick components from here. By clicking this AND gate symbol, we will get the list of all components available in the LT-SPICE. From this list, select voltage, click OK, and here now the mouse cursor point is attached with the voltage. To fix this voltage source in a particular location, just left click, then right click, then right click. First left click and then right click to fix the component in a particular location. Once more I am taking, suppose voltage, and okay. If I click the left click, then the cursor will be with the copy of the voltage source. So to escape, to remove this V3, we just click escape or right click. Okay. In these tools, there are two hand symbols are there. One is move and another one is drag. Using this move and drag symbol, we can move the component to anywhere. What is the difference between these two hand symbols? I will tell the difference between these two later. Just right click, then it will come to normal position. We can scroll up and scroll down the mouse for zooming and zoom out the circuit. Similarly by clicking, by hold and click, we can, by pressing and holding mouse left key, we can move the entire circuit. Okay, for the completion of the circuit, we need a resistor. Take resistor from here, just click. We can press Control plus R, Control plus R for rotating the. Just left click, then right click. Then we need a diode. Since we are characterizing the forward bias condition, the positive terminal of the battery should be connected to the positive terminal of the diode. So we need rotate. Just place here, then click right click. Then make a connection. Make wire connection using this wire tool. Just click on the wire tool. Click and make the circuit. Click right click. Then move and zoom. Then at last we need ground. For every circuit, it needs ground connection for the completion of the circuit. So just this is the ground tool. Just click on that and make a connection using the wire. By using the hand symbol, uh, move and drag, by clicking move symbol, we can suppose if we want to take out this diode, just click on diode and we can take it out from the circuit. If we want to rotate and place in the correct position, just click Ctrl R and keep in the OK position. Similarly, we can take out the component. But By using the drag symbol, suppose I clicked on this resistor, we can't take out the resistor, but we can drag on it. We can drag the position on it. You can't take it out from the circuit. This is the difference between the hand or move and drag hand symbols. Next, for the completion of the circuit, we have to put the parameters and specifications to these components. That is, here we have just a voltage source as V. We didn't mention how much voltage it is. Similarly, this is the diode. Which diode it is, we have to mention that. And the resistor value, we have to mention. So, such parameters and specifications we need to fill. For that, just bring cursor. First, we want to change the voltage. Bring the cursor over the voltage source. One hand symbol will come and right click. Then one pop-up will come. Just to put DC value as 5 volts. For example, here we are taking 5 volt DC source. Just click on that. Similarly, which type of diode we want? Bring the cursor over the diode. Hand symbol will come. Right click on the mouse. Pick new diode. These all are the diode, different types of diodes available in this space. You can take any diode IN914, IN4148. In my case, I am taking the normal diode, which is IN400. In some LT spaces, IN4001 will be not available. For adding, if suppose your system doesn't have IN4001, there is a small shortcut to add the diode component. I will tell that also. Here I am selecting the IN4001. Just click on it. Okay. Similarly, we can change the diode also. You can select any diode. In my case, I am selecting the IN4001. How to add IN4001 in your LT spice? For explaining that, go to your document file, open LT spice folder, just click open library file, go to CMP file. Then one file is the standard DIO diode. DIO for diode file. Diode file will be available here. Just right click, open with notepad. Then these are the specifications of the available diodes in the space. In below, you can add this. This is the code for IN4001 diode. Just to copy, I have already mentioned in the description. You can copy this one, you can copy this one, and open that folder. This one, open this standard folder using notepad and paste here. I already pasted in the below line. I already pasted here. Then close the window and restart the LT space. Then your diode IN400 will be available. Then come to the circuit, select the resistance value, right click, put resistance value as 1K. Also, go to simulate, edit simulation. We want voltage versus to current graph. That means in our x-axis, we require the voltage. X-axis will be in terms of voltage. So we need DC sweep. If our graph, if our, in our graph x-axis is time, we can choose fancy emitter. But in our case, in VA characteristics, voltage is in the x-axis. So we should select DC sweep and mention the values to provide the values. Name of the first source to sweep. What is the source voltage? Name of the source voltage is V1 here. Just provide V1. And the type of sweep we need the area. Starting voltage from in our graph, the x-axis will be start from 0 and stop from 5 volt and then increment from 0.0. Just click on that. Then we will get a dot DC command. Just place over here. Then we need to put some labels also. Click the label tool. We require two labels. First one is Vin, input voltage. This is our input voltage. Make the connection using the wire tool. Also, we need another label for output VO. I can place anywhere and make a connection. Now the circuit is completed and it is the time to simulate. For the simulation, click the run icon. Click run. Now a new window for simulation will come. This is our circuit part and this is the simulation. Here in this simulation graph, x-axis is start from 0 to 5. That is, in this here x-axis is the source voltage. But to get the VA characteristics, our x-axis should be the voltage across the diode. So we should change this x-axis from voltage source to the voltage across the diode. How to change the x-axis to the voltage across the diode? Just please bring the cursor to this part and we can see the scale symbol. Just right click on that. Here it is mentioned V1. Actually, now this is the V1 part. V1 means V1 is the voltage, source voltage. So now this x-axis is the source voltage. Actually, in VI characteristics, our V is the voltage across the diode. How to get the voltage across the diode? V0. Whether V0 is the voltage across the diode? No. V0 is the voltage across R1, output voltage. Output voltage here V0 is the voltage across R1. and V in is the voltage from the source. How to get the voltage across diode D1? How it is possible? We can find out the potential difference between V in and V naught. So V in minus V naught is the voltage across the diode. So we have to replace this V1 in the from x-axis of the simulation graph into V in minus V naught. For changing that parameter, bring cursor over this x-axis part and right click, change V1 into, change our V1 into V of V in minus V of V naught. That means input voltage minus output voltage. This V in minus V naught. That is equal to VD1. This is the voltage across the diode. Click on OK. Now our x-axis is OK. This x-axis shows the voltage across the diode. Then next we want to get current on y-axis. To get current on a y-axis, click, bring the cursor over diode D1. One red colored arrow symbol will come while cursor is over the diode D1. At the time, actually this arrow mark shows the flow of current through diode D1. Here also we will get the flow of current. Here also we will get the flow. Just click on that. Just left click. Just left click on that. Now our x-axis is came. This is the current through the. This is the current through the. This y-axis shows the current through the diode, and x-axis is the current voltage across the diode. This graph is the forward characteristics of the means the current while increasing the voltage source from 0 to 5, what happens? The diode voltage increases from 0 to up to 0.6 volt. So 0.6 volt. Just click on IAB1. Move the cursor. Then we can find out the proper value of current and voltage from this table. Instantaneous value of current and voltage we can measure from the maximum voltage is 604 millivolt. That means 0.6 volt. And the maximum current obtained is 4.4 milliamp. Voltage increases from, you look into the table. Now the current is not 0, it is microampere range, it's around 0. It starts increasing, current starts increasing, obtain its maximum value. This is the forward characteristics of a PN junction diode. Suppose if we are changing, what happens if we change the value of the resistance? what happens in the circuit? Suppose if I am changing the resistance from 1K to 100, what will happen? What will happen? The resistance, as the resistance decreases, current flow will be increasing. Current flow through the circuit means current through the diode will also increase. So it can stimulate once more. What we will get? Here we got a maximum of 44 milliampere. Before it was 4.4. Now we got 44 milliampere. That means current value increase, and also the voltage across the diode also increase. Just click on and move the cursor. We can analyze the maximum voltage and current. Now the maximum voltage is 1 volt. Current is 42 milliampere. Okay. This is the forward characteristics. Now, one additional thing we need to know that we have to find out the static and dynamic resistance of a forward condition. For finding static and dynamic resistance, just click on static resistance is the resistance. What is the static resistance? Static and dynamic resistance during forward bias connection. This is the static. Actually, we have already obtained the VI graph. The slope of the VI graph shows the resistance. Slope means here the starting slope is the initial time. If we find out the slope that corresponding to the static resistance, while obtaining the maximum peak of current, if we take slope, we will get the dynamic resistance. So to find out the static and dynamic resistance, we need two cursors. Just for finding static resistance, it is the initial stage of the click once more, then you will get the second cursor. You place first cursor and second cursor. Here, first cursor and second cursor. This is the graph. First cursor and second cursor. We need to find out the slope of this one. Actually, here the y-axis is the current and x-axis is the voltage. Slope means slope means the y-axis by x-axis. That means I by y. Here the slope is I by y. So that is the inverse of the resistance. So we need inverse of the slope. Actually, the resistance is equal R is equal to V by I. Means changing voltage divided by changing current is the resistance. But as our in our graph, x-axis is the voltage and y-axis is the current. Our slope will be, if we find out the slope here, the slope will be the inverse of the resistance. So finding the resistance, we should take the inverse of the slope. Actually, for the voltage and current values of both cursor 1 and cursor 2 are available in this table. If we move this first part, you can check out the cursor 1 current and voltage is changing. Similarly, if I am moving the cursor 2, you can check the voltage and current value of the cursor 2 is changing. Here, this part shows the difference between the horizontal values of the cursor 1 and cursor. Similarly, this part shows the difference between the vertical values of the cursor 1 and cursor. So this is the change in horizontal value, and this is the change in the vertical value. So here Actually, vertical divided by changing vertical divided by changing horizontal is the flow. So this is not our proper resistance value. So we need to take the inverse of this value. So if we take the inverse of this value, what will be the answer? 0.0360854. Inverse of this value will be 27. 0.036. The value will be 27. 27 ohm. Here the resistance value is 27. Now suppose we want to find out the dynamic resistance. We should change this cursor 1 and cursor to the end part. Take this part and find out the inverse of this value. Inverse of this ohm is 0.672428. Inverse is equal to 1.48. 1.48. Initially we got 24 ohm. In this case we got 1. Means the dynamic resistance will be smaller than the static resistance. As the current value increases from starting onwards, this part in this part, initial part, the resistance will be very high, so that the current is very less. This resistance is called as the static resistance, and dynamic resistance is the resistance when the current is in maximum range. This part is the dynamic resistance part. Okay, this is all about the forward characteristics of a PN junction. Right. Now I'm closing this part and coming to the circuit. Next, I'm going to discuss the reverse bias characteristics. Reverse bias. Reverse bias characteristics. In this manner, we can, by clicking this text option, we can provide headings. To make reverse bias, what changes are needed? In reverse bias, the positive terminal of the diode should be connected to the negative terminal of the battery. That means a negative voltage should be applied to the diode. In forward bias condition, we applied a positive voltage to the diode. In reverse bias condition, the negative voltage should be applied to the diode. So we have two options. Either we can rotate the diode, or we can apply, we can change the voltage value to the negative. For changing the voltage into negative, we can change also the dot DC parameter. Just move the cursor over dot DC, right click. It is the parameter for forward bias condition, starting from 0 volt to 5 volt. In the reverse bias condition, we are starting from negative volt. We are applying a negative volt, negative high volt, suppose negative 80 volt to 0 volt. This is the reverse bias condition. Maximum minus 80 volt. So the stop value should be the 0 volt. All others are same. Just keep clear. The dot DC parameters is changing. Now we can say that this circuit is in reverse bias. That means a negative 80 volt is applying to the diode. So that means this diode is in reverse bias condition. No any changes are other changes are required. You can just click on run. We got the reverse characteristics of the diode, means the voltage start from here. The voltage exactly shows the V of V in minus V of. That means this is this x-axis is the voltage across the diode, and this is the current through passing through the diode. So this graph is the is we can say that it shows the VA characteristics in the reverse bias. That means voltage from 0 onwards, 0, 7, 28, up to around 60, the current passing through the diode was 0 volt. 0 volt. If I zoom this part, you can say that just click on ID from 60 volt, from minus 60 volt onwards, diode starts conducting and go to maximum current 197 milliamp. That means this voltage is called as the this voltage is called as the reverse breakdown voltage, or this voltage is also known as the avalanche breakdown. This effect is called as the reverse breakdown or avalanche breakdown, Zener breakdown. We can say that in our IN 4001 diode, the avalanche breakdown voltage it could be in the range of 60 volt to 80 volt. It depends on the diode. If we change the diode, we can see that the forward, we can see that the reverse breakdown voltage, and similarly forward in forward condition also the forward 13 voltage may vary along with the changing the resistance, changing the diode. In the diode, when it occurs the avalanche breakdown, why it gets maximum voltage, maximum current, why it passes maximum current. That means in the avalanche breakdown condition, the diode will damage. The diode will damage and it will pass the maximum current. So this is the reverse bias condition. Similarly, similar to forward bias condition, we can find out the static and dynamic resistance in the reverse bias condition. We can find out by taking the slope of this part. We can find out the static and dynamic resistance of the reverse bias condition. For that, we need to take two curses, ID1 and one here, and one more. Click once more, we will get another pressure. Just to find the slope inverse of this line. That means 0.266 003 inverse is equal to, it is a 3 ohm. It is 3 ohm. And if it comes to this part, inverse of this slope means 4.62659 inverse equal to 0.21 ohm. Where it was 3 ohm, where it is 0.2 ohm. That means the dynamic resistance is always will be lesser than static resistance. So this is the this is the reverse bias condition, reverse bias characteristics the normal PN junction diode. Suppose if we want to get both forward bias and reverse bias wave characteristics in a single plot, how it is possible? How it is possible to plot both characters in a single plot, a single window? How it is possible? Easily it is possible by changing the dot DC parameter. Just click on that. Which start the start value we can put as -80 and stop value just put up to 5 volt because the diode voltage will be maximum 0.7. Just to put the 5 volt beyond 0.7. Just click here and click simulation. Suppose our x-axis values change anything, we should change the x-axis means v of mean minus v of v naught, and to find the current just click here. This is the graph. This is the graph. This part is the forward bias here. This part is the reverse bias means we can put in here 0. This is the origin one. Then zoom in this part. From 0 onwards, this is the forward bias condition, and we are going to fit this part. This part is the reverse bias condition. So this is the combined graph of both forward and reverse characteristics of the diode, which is similar to this graph. We can test with by changing the diode. We can, this cara is already we discussed the cara of D IN400. If we change the diode, why we choose before IN400? Because it is a normally available diode in our laboratory. Suppose I am taking IN914, the cara will be changed. Click on run. It is the cara. It is the characteristics of IN400. It is the breakdown voltage, reverse breakdown voltage is higher in the case of IN914. It is greater than 80 volt. That's why it is not shown here. Suppose I am taking another short key diode and simulate it. Here it is also like this. Change it to general diode. What happens? It is the VI characteristics of the general voltage. It also got cutting voltage. Forward breakdown happens at the maximum. Maximum of 0.7 volt. And the difference between the IN4001 and this Zener diode is that in the case of Zener diode, reverse breakdown happens as faster than the normal IN4001. because here the Zener breakdown voltage is near to 9 volt. It depends on there are different types of Zener diodes are also as shown in this. In the case of this Zener diode, the Zener voltage is around 9 volt. But as shown in the already seen in the previous case, that about IN 4001, the reverse breakdown was around 80 volt. So in the case of Zener diode, reverse breakdown starts soon. So for this reason, Zener diode is used as the voltage regulator. Okay, this is all about the VI characteristics of both forward bias and reverse bias conditions. If you have any doubts, you can put comments, you can put questions in the comment box. Thank you for watching.